Okay, so continuing on here with 3.1 on functions, let's take a look at just some examples. For this problem, we just want to find a domain. Very simply put, you cannot have 0 on the bottom, so we're looking for what makes that 0 on the bottom. So x plus 3 cannot equal 0. I solve by subtracting 3 on both sides, and I get x cannot equal negative 3. Cannot be negative 3, but it can be everything else. So here's how you'd write that. It can be negative numbers until it gets to negative 3. And you skip over negative 3, and you restart up, and it can be everything else, all positive numbers as well. Remember, you always write from lowest negative to highest negative, and this is the way of saying it can be everything except negative 3. This equation, you cannot have 0 on the bottom, so that cannot equal 0. What multiplies to give you 4 that adds to give you 5? 4 and 1. So I'm going to separate this into x plus 1 and x plus 4, which means x plus 1 cannot equal 0, and x plus 4 cannot equal 0. So I minus 1 on both sides. I know x cannot equal negative 1, and I know x cannot equal negative 4. So with that in mind, all numbers work except for negative 1 and negative 4. So here's how you would write that. All negative numbers work until you get to negative 4, and then you leap over negative 4, and then all numbers work until you get to negative 1, and then you leap over negative 1, then all numbers work the whole way to the end. Okay, the numbers that it's not, notice the gap. It can't be negative 4, so we skip. It can't be negative 1, so we skip. Under roots, you can't have a negative number, so this has to be greater than or equal to 0. Underneath. So you square both sides to get rid of that square root, and all you need to do is solve this now for t. So we divide by 3, and we figure out that t has to be greater than or equal to a third. So what does that mean? It means 1 works, 4 works, 18 works, 117 works, because they're all greater than a third. However, 0 doesn't work because 0 is not greater than that. So that means I put a bracket because it has a line underneath there because it includes 1/3 and it goes the whole way up to infinity. Right here, once again, remember, you can't have 0 in the denominator. Can't have 0 in the denominator. So, because you can't have 0 in the denominator, or sorry, not denominator, under the root. So you can't have 0 under the root, or sorry, a negative number. Let's start over. You can't have a negative under the square root. That's why it needs to be greater than or equal to 0. So I square both sides. Divide by, minus 25 on both sides. Negative x squared is greater than or equal to negative 25. I divide by a negative 1, but remember, whenever you divide by a negative, you switch the sign. And the square root is x is less than or equal to plus or minus 5. Well, what in the world does that mean? How can x be less than positive 5 and less than negative 5? What it really means is x is something in between the two. So when things start to look confusing like this, or with positive and negative, you're probably just going to need to graph it to take a look. So you pull out your graphing calculator and you realize, hey, it's a half circle. So what that means is it's actually in between 5 and negative 5 is what that means. That's what the graph looks like. So your answer is in between negative 5 and 5 because there's a line underneath it. It's always good to graph these anyway to see what they look like, because then you can get a good idea of where the graph is touching and where it's not touching. This one, do you see any fractions anywhere? No, there's no fractions. Do you see any roots anywhere? No, which means all real numbers are going to work, and that's how you'd write all real numbers, negative infinity to infinity. In this one, you can't have a negative underneath there, and you can't have 0. So, what does that mean? It cannot equal 0 and it has to be greater than or equal to 0. So, if it can't equal 0 and it has to be greater than or equal to 0, really what we're saying is it has to be greater than 0, because it can't equal 0 and it has to be greater. So, I square both sides to get rid of that. I add 3 and we find out that n has to be greater than 3. So, that means 3 is the lowest number up to infinity, and it's a curved bracket now because it can't include 3. There's not a bar underneath it. In this problem here, we have a root 4 minus 5t. So, got to worry about that root. It has to be greater than or equal to 0. Remember, can't have roots underneath. Can't have roots. With a root, you can't have a negative underneath. So, square both sides, get rid of the root. Minus 4. Divide by negative 5. So, we know that t has to be less than, because you got to flip the sign, because when you ever divide by a negative, you flip the sign. T has to be less than 4/5. So it goes from negative infinity up to 4/5, and you put a square bracket there. And it's written this way because, remember, from negative infinity to the highest number possible. So there is the domain. No roots, right? No roots. No fractions, no fractions. All real numbers then. And you write that as negative infinity to infinity. If you have any questions or concerns on finding these domains, I hope that helped. That was a ton of different examples of how to find domains. So that's probably the toughest part in this section. So if you can figure that out, I hope that these examples helped.